Now let us take up a problem on series parallel combination of capacitors. So in this problem we have a battery which has a V of 18 volts. So this battery maintains a constant potential difference of 18 volts across its terminals. This is connected to two capacitors C1 and C2 which are in parallel, and this is connected to another capacitor C3 that is in series with this combination, and this is the circuit given to us. C1 is given as 12 microfarad, C2 is 6 microfarad, and C3 is 18 microfarad. First job is to find the equivalent capacitance. So that is very easy. These two are in parallel. Okay, so capacitance will get added. So we'll have 18 volts here. Let's simplify the circuit step by step. Okay, there's a reason for that. So this is what we get. This is C3, which is 18 microfarad, and this is C1 and C2 in parallel. That will give us a capacitance of C1 plus C2, which will be equal to sum of these two, 18 microfarad. In parallel, okay, capacitance is added. So we get 18 microfarad, and this C3 is also 18 microfarad. So this is equivalent to this. Now these two are in series. When two same capacitors are in series, equivalent capacitance is C by 2. Or we can say equivalent capacitance is product by sum. And if you don't like all this, you can always use 1 by C equal to 1 by C1 plus 1 by C2. So therefore this will be equal to 18 volts. Here this and this in series will give me 9 microfarad. Because same capacitor in series, okay, capacitance becomes half. Okay, or use 18 into 18 by 18 plus 18, that will also give you the same answer. So this is the equivalent capacitance, 9 microfarad. The second part of this question is more interesting. It is telling us find the charge on each of the capacitors. So now to find the charge on each of the capacitors, we start from here. This is one battery, one capacitor. We can find the charge very easily. So this charge will be equal to C into V. 9 into 18. So 9 into 18 will give us 162. So 162 microcoulomb is the charge on this equivalent capacitor. And this equivalent capacitor has come from two capacitors in series. So therefore Q will be same. In series combination of capacitors, Q is same. So this 120 microcoulomb Q, same Q is there on this capacitor and this capacitor. In series, Q is same. So whatever Q is there in the equivalent capacitor, same Q will be there on both the capacitors in series. And this is nothing but this C3. So now we have found the charge on the third capacitor C3. So Q3 will be equal to simply 162 microcoulomb. This is having 162 microcoulomb charge. This is having 162 microcoulomb charge. Because these two in series have become this. In series Q is same. So whatever Q is there in the equivalent, same Q will be there on the two capacitors in series. Now once we have found the charge on this, 162 microcoulomb, and we know the capacitance of that, the equivalent capacitance of that is 18 microfarad. Now we can find the potential difference here. So V will become Q by C. So here Q is 162 and we divide by capacitance, which is 18. So this will give us 9 volts. This is the potential difference across this capacitor. This also will be 9 volts. This 18 volts is getting divided between these two capacitors, and these two capacitors are exactly identical, 18 microfarad each. Therefore V will be equally divided and we can get that mathematically as 9 volts. So the potential difference across this capacitor is 9 volts, and this capacitor has come from these two in parallel. In parallel, V is same. So whatever V is there across the equivalent, same V will be there across each of these capacitors. So that 9 volt is the potential difference across this capacitor and this capacitor, because these two in parallel gave us this. In parallel V is same. So V will be 9 volts. And once we understand that, the charge on this capacitor will be this C1, which is 12 microfarad, and that is 9 volts. So 12 into 9, 108 microcoulomb. And the charge on this capacitor will be its capacitance, which is 6, and the potential difference is 9. So 6 into 9. So that will give us 54 microcoulomb. So we have to remember that when capacitors are in series, Q is same. When capacitors are in parallel, V is same. So these two capacitors were in series, and this was the equivalent capacitor for these two. So all these three will have the same charge. So we found the charge on this. This is the charge on this and this. And this has come from these two in parallel. So parallel V is same. So we found the potential difference here. And that V is same as the V across these two capacitors. And then to get the charge, we multiplied C into V. And we got the answer.